Imagine building a house. You start with a vision, a blueprint of what you want to create. This blueprint guides every step of the construction process, ensuring that each brick is laid in the right place and every beam is properly aligned. You need strong materials like bricks and mortar. These materials form the foundation and structure of your house, providing the strength and stability needed to withstand the test of time. You also need tools to put everything together. Hammers, saws, and drills are essential for shaping and assembling the materials into a cohesive structure. In the world of computers, programming languages are the building blocks and tools. They allow us to construct software applications, much like how bricks and tools help us build houses. C and C++ are two of the most powerful and widely used languages. They have been the backbone of many software projects, from operating systems to game engines. They are used in everything from simple calculators to complex video games. Their versatility and performance make them ideal for a wide range of applications. Learning C or C++ is like learning a valuable skill. It opens up a world of possibilities, allowing you to create software that can solve problems, entertain, and innovate. You can use this skill to create amazing things. Whether you're developing a new app, designing a game, or working on a complex system, the knowledge of C and C++ will be invaluable. But which language is right for you? Each has its own strengths and weaknesses, and the choice depends on your specific needs and goals. This essay will explore the world of C and C++. We will delve into their unique features, their similarities, and their differences. We will learn about their history, their strengths, and their weaknesses. Understanding these aspects will help you make an informed decision about which language to learn and use. By the end, you will have a better understanding of which language to choose for your programming journey. Whether you decide to master C, C++, or both, you'll be equipped with the knowledge to build your own software creations. Before we dive into the details, let's take a step back in time. C was created in the early 1970s. It quickly gained popularity for its efficiency and flexibility. Think of C as the reliable, sturdy foundation of a house. C++ came later in the 1980s. It was designed to build upon C's strengths. C++ introduced new concepts like object-oriented programming. This made it easier to build large, complex programs. Think of C++ as adding walls, windows, and a roof to our house foundation. C is a procedural language. This means that it follows a set of procedures or steps in a specific order to perform a task. Unlike other programming paradigms, procedural programming is straightforward and linear, making it easier to understand the flow of the program. This means that it focuses on writing instructions step by step. Each step in the program is executed in the order it appears, much like following a set of instructions in a manual. This approach makes it easier to debug and maintain the code. It's like writing a recipe. Just as a chef follows a recipe to prepare a dish, a programmer writes code to perform specific tasks. Each line of code is an instruction that the computer follows to achieve the desired outcome. You tell the computer what to do in a specific order. The computer executes these instructions one by one, ensuring that each step is completed before moving on to the next. This sequential execution is a hallmark of procedural programming. C is known for its speed and efficiency. It is a powerful language that allows developers to write programs that run quickly and use system resources effectively. This makes it an ideal choice for performance-critical applications. It's like a race car. Just as a race car is designed for speed and performance, C is designed to execute code rapidly. This speed is crucial for applications that require real-time processing and quick response times. It can execute code very quickly. This ability to run code at high speeds makes C a preferred language for developing operating systems, game engines, and other performance-intensive software. This makes it ideal for system programming, embedded systems, and high-performance computing. C's efficiency and control over system resources make it a go-to language for developing software that interacts closely with hardware. Operating systems like Linux and Windows are written in C. The language's ability to manage hardware resources and perform low-level operations makes it indispensable for system-level programming. However, C can be challenging for beginners. Its syntax and concepts can be difficult to grasp for those new to programming. Additionally, the language requires a deep understanding of how computers work. It requires careful memory management. Unlike higher-level languages, C gives programmers direct control over memory allocation and deallocation. This control is powerful but also comes with the responsibility of managing memory correctly. This means you need to tell the computer how much memory to use and when to release it. Proper memory management is crucial to avoid issues like memory leaks and segmentation faults, which can cause programs to crash or behave unpredictably. Section 4 C++, Embracing Complexity with Objects. C++ takes everything from C and adds more features. It builds upon the foundation laid by C, introducing new concepts and tools that make programming more efficient and powerful. One of the most important is Object-Oriented Programming, or OOP. OOP allows developers to create objects that represent real-world entities, making code more intuitive and easier to manage. OOP is like building with Lego bricks. Each piece or object can be assembled in various ways to create complex structures. This modularity is key to managing large code bases. Each brick is an object with its own properties and actions. For example, a car class might have attributes like color and speed, and methods like accelerate and brake. With OOP, you can create reusable pieces of code. These reusable components can be used across different parts of a program, or even in different projects, saving time and effort. This makes development faster and more organized. Teams can work more efficiently, as they can easily understand and modify existing code without starting from scratch. C++ is used extensively in game development, graphical applications, and large-scale software systems. Its performance and efficiency make it a top choice for demanding applications. C++ is more complex than C, but it offers greater power and flexibility for handling complex projects. This complexity allows developers to fine-tune their applications, optimizing performance and resource management. Embracing the complexity of C++ can be challenging, but it opens up a world of possibilities. By mastering its features, developers can create robust, high-performance applications that stand the test of time. Section 5 C versus C++, a head-to-head comparison. Let's compare C and C++ side by side. Feature programming paradigm C, procedural C++, object-oriented feature speed C, very fast C++, fast but slightly slower than C feature complexity C, lower C++, higher feature, memory management C, manual C++, manual and automatic using smart pointers, feature, typical use cases, C, systems programming, embedded systems, C++, game development, large applications. Section 6, choosing your path C or C++. So, which language should you learn? The answer depends on your goals. If you want to work on operating systems or embedded systems, learn the fundamentals of programming and focus on speed and efficiency, then C is a great choice. If you want to develop video games or graphical applications, build large, complex software systems, and learn object-oriented programming, then C++ is the way to go. Section 7. The future is written in code. C and C++ have shaped the world of computing. They are powerful languages that offer endless possibilities. Learning either language is a valuable investment. It opens doors to exciting career paths and the ability to create incredible things. Whether you choose C or C++, remember that the most important thing is to start coding. Practice, experiment, and never stop learning. The future is built on code, and you can be a part of it.